Alright guys, welcome back to Tech Tanks. We're going to be doing a two-part video on memory buffer overflow. Specifically on these two videos we're going to be talking about a stack overflow, not a heap overflow. I'll cover that in a different video. Also, this coverage is going to be enough to just help you with enough of an understanding to get through the CEH and even to exploit it. If you come across and like hack the box or whatever the case may be. But if you want to get a full comprehension as far as for every bit of the detail, you're going to want to do a little bit more research. We're going to just cover what you need to know to be able to take advantage of it, okay? So with memory buffer overflow, the whole point of this kind of exploit, there's actually two different things you can do with it. You can do a denial of service, potentially, or, and this is the better route to take, you can manipulate the application to executing something you want it to do, not what it's supposed to do. Alright, so to kind of help with that explanation, we're going to start looking at these, or looking at our lab setup here. Let me pull this up. There we go. Well, hopefully that's not going to cause a problem. I should put a third monitor on here. Anyway, so we're running currently the Kali system, as you can see right in front of you. And then we also have our Windows system up, okay? And the screen's pretty small, but when we're going to really jump over here and use it, I'll make sure we make it bigger for you guys. And actually, that's where we're going to start. So let's go ahead and just go back here. There we go. Okay. So to understand what memory buffer overflow is, or buffer overflow is, found this little image online. Again, this is going to be like a 10-foot overview of it. So when you set up a function, or specifically when you set up a variable in programming, which as you can see we have a little something here, and I'll show you guys that in a moment. It pulls up its little stack of memory and the address and all that stuff. Your goal is to go beyond what is allotted for that variable so you can overwrite different things. Okay, so this is the area that's set aside, like the memory space that your variable can take up. That's what's set aside for it. But unless in the programming code there is something to prevent it from going beyond that, you can actually overwrite the next parts of the memory address and things like that. This is where it becomes a problem for the application. It can cause the application to crash. Okay. Now you can find online, if you're familiar with programming, you know that every variable type has a limited amount of space that is reserved for it. If you go beyond that space, you either need to split it into multiple variables, or you need to change the size of the variable. So for example, if you have like a character list or a string or an int, they all have a limited amount of size that they can have. Sometimes you dictate that size, sometimes it's just automatic. Okay, so our goal is we're going to overwrite this section. Okay, now we're going to go ahead and just get rid of that for now. We're going to come over here, and I'm sure you probably can't read that right now. There we go, that's nice and big. Okay, so this is a simple C application, alright? And all it's basically doing, if you're not familiar with programming, so this, first of all, just overwrites a warning that happens right here. This is an unsafe function, and so this just tells it to ignore the warning for the unsafe function. So anyway, with the starting of this program, you provide an argument. And this is just like for argument count. This is the character list. After you supply it, it's allowed to be this size. If there's less than, if these two things are not filled, then it will state that there's an error. You must provide at least one argument. And then it just copies it, and then it ends the application. Like, that's the end of it. It's a very, very simple program. And this is just to demonstrate. We're not going to run this one. We're actually going to use a different one for this demonstration. But this is just to give you an idea of kind of what's allotted. So this character list, which I refer to as buffer, is allowed to have 64 bytes on in it. Okay, that's it, done. If you supply 65, you've now just overwritten um, that allotted space, and that's where it starts causing problems. Now, the problem depends on the size, right? So, if you barely overwrote it, there are times in which I've seen applications continue forward. It might be a little buggy, but it worked. Then there are times where it will completely crash the application. And then if you completely crash the application, that's actually kind of what your goal is. And this is part of the reason why pen testers will have a lab setup with multiple operating systems. If you're attacking a Windows 10 system, like this one here, and they're running, we'll say this application right here, this server, which is what we're going to be using, you can get a copy of it, set it on your system, and that way you avoid causing problems on the system you're going to be pen testing. Or it makes it to where you have all the time in the world to test it out, right? So we'll get to that part in a moment, but this is the idea here. Now this is effective if there's a string, an integer, a float, whatever the case may be, whatever variable type you're assigning, they all have their limitations. Okay, now ways to ensure that it doesn't go beyond that is limit the amount of input accepted. You can do that by checking the variable size or limiting the space. So most of the time you're not going to be using a console application, right? You're going to be using a GUI interface. And if you're using a GUI GUI interface, graphic user interface, when you're using a GUI, you have like a text box, or you have some kind of input box. If you limit in that input box saying that the value cannot exceed X amount of characters, or the numerical value cannot exceed X amount of a value, then you prevent it from doing anything else, right? Now when it comes to web applications, you need to also verify that server side, not just client side, for the record. We went over that in a different video. So all you got to do is sanitize the input, and you will prevent it from happening, right? It's very simple to do, actually. I've written plenty of mobile applications and computer applications, and the solution is literally, depending on the scenario, an additional line of code. That's it. Very simple. Now there's a lot of other sanitation you need to do, such as if you're expecting an integer, you want to make sure they put in a number, not a string. If you're expecting a string, perhaps a number is acceptable, don't know, but if it's not, then you need to make sure that they don't put in a number, right? They put in alphanumeric or alphabetic characters. Sorry, coffee break. I'll probably start doing some programming videos in the future. Right now I do want to keep focusing on the cyber part, but anyway. So this is what our goal is here, is to just simply overwrite this space, okay? So we're going to go ahead and get that going. So what I did was I just Google searched Vuln server. You can find it, download it, and then we'll get it going. Now if you want to run this, you will need to shut off your firewall, at least on this system. Okay, so if you're doing it on a system that is able to reach out to the internet, which right now this one currently is, make sure you have a external firewall. So the firewall we're shutting off is the internal one for this particular system. So I still have a firewall on my network that is covering my network. Okay, just as a precautionary FYI. We're going to go ahead and run this as administrator. And yes. Okay, and this is all the server is. Okay, it's just now it's waiting for a client. So we're going to go ahead and put that over here. And then Immunity Debugger, you can download that for free as well. Fantastic little device, but it's going to be very annoying looking when you first pull it up. I'm telling you now, because it's a lot if you're not accustomed to what you're looking at. That black screen is a bad example. Just give me a moment here. Okay. So what you're going to do is we're now going to attach this, and both of these do need to be running as admin for this, okay? So Vuln server right here, go ahead and just attach it. And my screen got all sorts of screwed up. Alright, so when you first open it, it'll probably already have these kind of divided out a little bit. Because I've been minimizing this virtual machine screen down to like nothing, it has caused it to kind of screw with my visuals here. So I'll just make some quick adjustments so that way we can see everything. And I'm just trying to see. Alright, we're going to want to expand this. You don't need to see every little detail of every column, don't stress it, but I do like to at least have a pretty decent view of things. Have a little separation as well. Okay. Alright, cool. Alright, so here's your memory registers. And to just kind of sum it up pretty quickly, this is the one we're aiming for, the EIP, okay? This this mess right here is basically where your strings are, your system calls are, and all sorts of stuff. So we'll go through that probably later, but for now, this is just kind of your memory addresses and values, your hex dumps, so on and so forth. All right. So what we're going to do here is, let me see if I can actually make this smaller without ruining this. And I ruined it. Of course I did. There we go. That'll work. Perfect. So that way we can also see this. Okay. So first of all, the first thing I want to point out is notice that this is paused. Okay. So we are going to want to kick it back on. Okay. Now, Vuln server typically runs on port 9999. So let's go ahead and connect to it. There we go. Cool. All right, so just real quick, and we're going to be kind of bouncing back and forth here. It's going to be a lot of fun. Crap. I'm trying to think of what the... I think I know. That should be it. Okay, so you can see welcome to vulnerable server. Okay, there's a list of commands that we can run, which, oh, what the hell? There you go. Okay, better for you. All right. So this is not overly relevant, but I'm going to show you guys. First thing we're going to be doing is sticking the application. We're going to be putting through various things to test and see if there's a vulnerability. Okay. So we're going to go ahead and exit out because we don't need that part. And I have a overflow stick example here. So what we're going to be using is generic send TCP. Okay, if you type that in and press enter, it'll show you what you need to do is have the host IP, which we have the port number, a spike script, and then you can set your skip variables and your skip string. We're not going to worry about these. Okay, that's outside of the purview here. So to run this, you do need to have your spike scripts. Now I have a couple of them here. They are very, very, very simple to write. Okay, I have this one, so you can see where it's just s read line, s string, l time, s string variable, 0. Okay, so what this is going to do is just spit out a bunch of values at this web application, and it's checking to see if there is a vulnerability. Okay, now the l time is, well, probably should have pointed this out before. Right here. So you see, like, we have l-time command that we can run, stats, trun. Okay, these are the three that we're going to be running, is l-time, stats, trun. Now, when you run these tests, typically, you will run them until the end. we're not going to do that. I already know which one of these is vulnerable. So for the sake of brevity, we're going to be doing it for, or we're going to test all three, but we're going to test them for like 20, 30 seconds. Enough for me to just show you what it's doing to the application. Okay. Actually, one of them is going to take like a split second. Okay, so the way we run this is we're going to do generic, there we go, send TCP, and then this is just kind of a reminder of what it is we need. So we need 192.168.58, 132, 1234, okay. And then the first one we're going to do is we'll run the stats spike, and then we're going to just do 0, 0, okay? And this is going to start blowing stuff up. Okay, so right now what it's doing is it's just fuzzing everything. Now what I want to show you. Okay. I'm going to shut this off for a second. Okay. Alright. If you notice on this side, this is our application running. Clearly it's doing a bunch of stuff over here, right? So I'm going to go ahead and stop our thing from running. This has been running long enough for me to show where it doesn't look like there's much of a vulnerability there, right? So we're going to do the same thing again, but this time we're going to be doing it to the L time. There we go. So just to kind of show you what I'm doing here real quick, we'll get rid of this part. So now it's, you know, the L time. That's what we're going to be doing. Okay. Other than that, it's the exact same thing. And then we'll send it through and back to this mess of a good time, right? You can just see it just kind of flying through on the connections right here. So again, this one is not vulnerable, so we're not going to take a whole lot of time going through it. And let's see here. So we're going to go ahead and stop this. Okay. Now, in case I forgot to mention what this specifically is, Immunity Debugger is a debugging application. Okay, the entire point is to be able to put stops where you need to check how the application is running, points of memory being accessed, so on and so forth. So this is a great thing if you have an executable file where you can put it against the debugger and kind of see what's going on where. Okay, again, for this sake, we're simply I'm trying to show you what the overflow itself is. I can tell you the CEH will not demand that you do it. Okay, it just needs a theoretical understanding. So, and what I'm going to be showing you, like I said, will be enough to understand how to do it. But that's all this is basically seeing, you know, what's in the memory at what point, when the system calls are being made, so on and so forth. You can search for specific strings, lots of good stuff. So Immunity Debugger, I definitely recommend getting familiar with. Okay, so we have now tested L time, stats, and so far everything's running fine, right? So now what we're going to go ahead and do is we're going to do the exact same thing that we've been doing, only this time we're going to do it for Trun, right? Because I said that those were the three we're going to do. So I guess for the sake of thoroughness, so there you go, Trun. And I'm actually not going to show you this screen when I execute it because I want you to see what happens over here. This is the vulnerable one, and you're going to see where down here it is going to instantly jump to pause, and this is going to stop moving. It's going to be a good time. All right, so I'm going to go ahead and send it. Boom. Okay, now on Kali's side, it's actually still doing its thing, but on here everything stopped. Okay, so I'm going to go ahead and stop Kali because we don't need it right now. And then what we're looking at here is our memory space. Okay, all of a sudden you can see this stuff is filled with A's all over the place, right? And this is actually the one we care about most, okay? Your instruction pointer, or your EIP space. Now it has the value of 41414141, which, if you know your hex, that's A. So it's A, 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 A. All right? So this is vulnerable. So it's like, okay, well, that's good. How vulnerable is it? Right? You know, that same old question. You know, and the reason why we care is if we can overwrite this, what EIP does is it says, okay, go here. It points to the next space to execute. All right, so if you think about that for a moment, in an application, you have, you know, 1,000 functions written and blah, 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 blah. And when something completes, it points to, okay, now go execute this function. And then every call has its own stack, you know, and so everything has its own EIP. If we can control the EIP, where it points to, where it's going to execute next in the application, we can put through our own malicious code, and then we can have it point to it, right? So there's a few things we need to know, and this is where we're going to be splitting, you know, this into two different videos. The first video is going to be this part, and then I'm going to show you how we can figure out how to stop the EIP directly, because we overshot this, right? And so just if you look at all of our memory space down here, I mean, we overshot it. Trust me, we went beyond the EIP. We need to know exactly where that falls, because if we know exactly where that falls, then we can manipulate it, right? We can put in our own memory address to execute, and that's the goal. So what we're going to do here, we're going to switch back over to our Kali system. And what the heck did I just do? Sorry, what you guys aren't able to see is that I just totally got rid of my video recorder software thingy. There we go. Okay. Whew, that was crazy. All right, so we're going to go back over to, actually no, before I go back over to the Kali system, I need to reset this because it's broken. So what I'm going to have to do is restart Vuln server, which you will see. Let's see if I hit this. Memory address is not readable. So try to change EIP or pass exception program. So yeah, that's EIG. The EIP is not readable. So we're going to close it, and then notice Vuln server just automatically closed as well. This is the annoying, tedious part. Every time you crash it, you have to restart everything. Every time. It's a lot of fun. It's a good time. Oh, I gotta attach this. I almost forgot. Vuln server. Attach. Bam. Okay. I'm gonna go ahead and move this. Okay. So, there's a couple things we can do here. Now, for today, let's see, how much time do I have left? Yeah, I got a few minutes. Okay. So there's two scripts I'm going to show you guys. Now, typically these are found in the user share Metasploit framework tools directory, but I like to actually have them on in a different space. So in my scripts directory, I actually have a buffer overflow section. And this is just for the sake of sanity, and I don't have to worry about hunting. Oh, I want to so you guys can see what I'm looking at, huh? I don't want to have to type in some ridiculously long file path to access these two. Okay, and then the Fuzzer Python script is honestly, it's a simple Python script that you could find, you know, minor variations out there. It's pretty easy to find, or you can write it on your own if you know your Python. But what we're going to be focusing on here, just as a quick example, is how to create a pattern for your buffer, and then how to find the offset, which that'll make sense in a minute. So for the pattern, you could just, right here, I'm going to just type in pattern. What the heck? Huh. Pattern. Weird. That's kind of odd. All right, let's try this. So we're going to go scripts. Buffer. There we go. Now it's working. That was weird. Okay. And then you got to feed it the length that you need. So you can do like 100. It'll give you 100, 1000. Do that. Okay. You can see this. So this seems randomly generated at first glance, but if you really look at what it's doing, it is not even close to being randomly generated, right? So yeah, there's a method to the madness. What appears to be madness. So, with that being said, let's go ahead and let's at least send through some here real quick. But okay, so we're going to do, I don't know, 2500. Spitball number out there, okay? And then what you're going to want to do is copy this. Okay, now you could do this manually or you could do it with the script. I actually have not tried it manually, so I kind of want to do that. So we're going to do NC, NV, 192, 168, 58, 132, 1234, boom. Ah, crap. We have to start the application. There we go. Whew. Almost had a problem there. All right. So help, and then this is what we're going to do. So we know trun is vulnerable, and then the trun value. So what I'm going to do is just type in trun, and then we're going to blow it up. Okay. This should be entertaining. Now, before I press enter on this, I lost my stupid thing, didn't I? I did. Biscuits and gravy. All right. Well, I'm going to have to minimize this for a second, or make it smaller, rather. I know, it looks ridiculous. I get it. All right. Sorry about that. Okay. So, before I submit this, I want to switch this over to the Windows system. Okay? So all I'm going to do from here is press enter. And I want us to look. What is going on here? There we go. Okay. And so we're looking at that. Perfect. Sorry. I'm having problems with my video screen. And then we're going to go boop. And trun complete. What do you mean trun complete? Trun's not supposed to complete. That didn't do what I expected it to. Let me see what I did wrong here. I'm sure I did something wrong. See, this is why I like to use scripts, though, because I don't screw up on scripts. That sounded a little arrogant. Let me see here. CPA. Wait a second to see what I did wrong. Scripts. I don't know what I did wrong. That's crazy. Should have worked. Well, tell you what, we're going to do this. I went ahead and moved over a script so that way we can look at that. I'm going to look into why that didn't work. I'm curious. That's irritating. So, alright, I moved over my Fuzzer script over here. So what we're going to go ahead and do is, for sanity's sake, we're actually going to edit this in gedit. We'll see why in a moment. So, this nightmare is going to just, boom. Okay, that part's taken care of. There we go. Alright, so we have that part. We're not ready for this, so we're going to get rid of that. We're not ready for this, so we're going to get rid of that. Nope. Yep. Oh, that's what I did wrong. Forgot to put that part in. Okay, well, this should work now. This should blow it up. I hope so. Alright. So, yeah, we got this. Alright. So what we're going to do now is just do Python, Fuzzer. Alright, let's switch it back over to Windows. Now it should work. And if not, I'm going to lose my shit. I'm going to be a little irritated. Nope, it worked. We blew it up. Cool. Alright, so if you notice, down here, we get the pause screen again, right? And you can see where we got this just nightmare of information. And then what you want to look at, again, we're aiming here, right? So keep that value in mind here, and let me switch her back over to, okay, so I'm going to come back over here, and that script that we ran before, it had a we'll call it a sibling script, the offset script. Okay, and again, you need to do, okay, what was the size of it before? I think we did 2500. I'm really hoping we did 2500. And then you add the Q flag, and then you're going to put in the value that was in the EIP space. Okay, 4337, that should be it. Exact match is at 0.2003. Okay, now we're going to do one last thing, and then we're going to call it a day. We're going to go back to our fuzzer. Okay, and we're actually going to get the EIP ready. Okay, we're going to allow for, because what we want to do is we want to put 4 B's in the EIP, okay, which is value 42424242. That's what we're looking for. Now we need to change this, right? We need 2003 spaces. So exit, exit. Oh, that's right, it's broken. I forgot it's broken. Hold on just a moment, I gotta restart this whole thing. Like I said, when you break the application, every time you're gonna have to reset it. So where we broke it, now we gotta put it back on. So all I'm doing in the Windows system is kicking it back on. And I'm gonna reattach the Vuln server to Immunity Debugger. Okay. Alright, everything's back up. We have it running. Perfect. Alright. And then we're going to go ahead and do Python. No. What I'm going to do is this scripts, buffer, let's see, Python. No, man, why am I really want to run Python right now. So we're going to do create, and then we're going to do a length of 2003. Okay? Because remember, that's where the exact match at the offset was at. So we have that. And copy it. See, this is why I like to do it here, because sometimes when things don't want to move over, force it. There. Be a pain in the butt. I'll teach you. Alright. Oops. So we got that. Now we have our EIP. Now what we want to do is switch this to offset plus EIP. Okay. And save that. And so our goal is, like I said, for EIP, we want it to have values 42, 42, 42, 42. Okay, so we're going to just run the Python script again. And then, sorry, I know, I got to screw up the view. That's all right, though. We're not going back to Kali. All right. Now, if we look here, we executed it, and first of all, pause, because we broke it again. And EIP is at value 42, 42, 42, 42. That is hex for B. Okay? So what we needed to do is we found out it was vulnerable to the buffer overflow. Then what we needed to do was find out, okay, well, how many values does it take to overflow? That was our first thing. And we started at 2500. And it's like, okay, perfect. That's quite a bit. And then it was, all right, now if we look at the value of the EIP section, what is the pattern that we had there? And then by putting that back into our, locate the offset type script, we were able to find, okay, it's in this exact space. We now control the EIP. Okay. Now in the next video, we're going to talk about what do we do next. Okay, so we control the IP. That's great. Now what? And I mean, spoiler alert, we're basically going to continue seeing where we can put additional data, because we need quite a few bytes in order to put in like shellcode, for example. Okay, so that is going to be the next video that we run, but this is part one. I hope you guys enjoyed this part of the video. Watch it a couple times if it's a bit of a struggle, getting this. It's a complex topic. This is one where a lot of people do struggle. If you have some programming background, it's probably a lot easier to understand. But that's the end of this video, guys. I hope you enjoyed it, and I will catch you on the next one. I'll try to have the next one up in the next couple days. Definitely the weekend at the latest.